Hi guys, welcome to this tutorial on esoteric tech. The topic of this lesson today will be functions. If Go is the first programming language that you've ever worked with, I can promise that this video is going to be very informative, very educational. If Go is not your first language, you'll be happy to know that Go is similar to languages like Python and JavaScript in the sense that it handles functions like first-class functions. But similar to structs in Go, Go has its own twist on functions. Some are improvements and some are kind of experiments that should be avoided, and we'll discuss both within this lesson. So far, we've seen functions being used in pretty much every tutorial that I've done. The common function has been the format.println function, which prints something out to the console, but we've also seen the main function, which is the entry point to all programs, and it's kind of a special function that automatically gets run whenever you execute a Go program. So we'll talk about that more, but this is kind of the agenda for the day. We'll first talk about why we use functions. We'll discuss and go through how to define them. We'll give an example of how to create custom functions, and then I'll discuss what to expect in the next lesson. Because functions are such a large topic, there's no way I can cover all of it in one. And as usual, if you guys find these tutorials to be helpful, please do subscribe and like. That feedback is always appreciated. So let's get started. Why use functions? Well, functions give us the ability to reuse code so that we don't have to keep writing the same thing over and over again. And I'll give you an example of that in a bit. But functions also give us the ability to write clean, modular code. And I've got an example of that below with this picture of a desktop. Most people probably haven't ever bothered to assemble their own desktop. But if you have, you realize that most of the pieces within the desktop are very modular. They can be swiped out easily for upgrades. So if you wanted to replace the hard drive or the CPU, you can go out and buy another component, an upgraded component, and switch that out as long as it has the same connection. So really, as long as it receives the same input and gives the same type of output, it can be easily replaced. And that's what I mean by modular. And we'll give an example of that later. But as I mentioned, it allows you to reuse code. So one function that we've seen a lot is this format.println function. And at the bottom here, I've actually got the actual documentation from the Golang website of the println function. And we can see here that whenever you call this function, it actually returns the output of another function, f.println. And that function is defined right above. And so essentially, whenever we call this println function, we're calling fprintln with a few additional parameters, and it's executing all of that code within that function. So imagine if you had to write that code every single time you wanted to print something out to the console. Thankfully, we don't, because functions exist. And so functions, as you can see, save us quite a bit of effort and time in terms of not having to retype things over and over again. And at a high level, functions are really about inputs and outputs. It's about providing your function with some data, some input, something to work with. It performs some type of calculation or some job, and then it creates an output. And that output can be in different forms. It may be printing to the console, it may be returning an actual value, but as I said, at a high level, it's about inputs and outputs. So how do we define a function? Well, there are 4 key parts to defining a function. The first one is the keyword func, and that's obviously short for function. The second part is to actually use the name of the function that you want to give. So if I want to create a function called calculate sum, that's exactly what I put in there. And then that is followed up by the parameters to that function. So in this function that I'm creating, I want to pass in 2 numbers. And you always follow up the name of the parameter with the type. So if this was just taking, one parameter, I just would have said num1 int. But because I'm using 2, I need to separate them with a comma. And your parameters are always placed inside of parentheses. And then the last part to defining a function is actually to indicate the return type. Not all functions have a return type. It's possible to have a function that doesn't return any type of value from it. But if it does, then you need to indicate that type. And it's also worth noting that if your function is returning some value, then you have to use the return keyword as indicated here in this function. It's also possible to return more than one value from a function, and I'll give an example of that as well. But I think that's enough theory for now. Let's go ahead and hop over to the code, and I'll show you guys some examples. All right, so here we are in our main.go file. Now, normally when I switch over to the coding portion of these tutorials, the main function has already been typed out. But for the sake of this tutorial, since we are covering functions, I haven't done that yet. So as I mentioned, you always need the main function to execute a Go program. The one exception where you do not need a main function is if you are writing a package to be imported as a library for another Golang program. But in order to execute a program, you always need that main function. So as I said, you always start with the func keyword, followed by the name of the function. The main function takes no parameters. It has no return types. And I'm not sure if I mentioned this, but all logic for a function has to be enclosed within curly braces. With other programming languages, it's okay to have that opening curly brace on its own line, but with Go, that is not allowed. You always have to have that opening curly brace on the first line that the function is defined on. So we're just going to play around with that calculate function that I just showed you guys in the PowerPoint. So first thing I'm going to do is just going to define a couple of variables. So I'll do first num is equal to 2, and I'll do second num is equal to 4. So those are going to be our inputs, our parameters into that calculate function. And I believe the name of the function was calculate sum, and it took in a couple parameters. Second num, okay. And actually I'm going to have that return a variable. So we'll say my sum is equal to calculate sum, right? And so now it's giving us that error there because we haven't actually defined this function. So to do that, I'll go down a couple lines, and we've got that func keyword, calculate sum, and then we said we're going to put in the parameters. You type the name followed by the type. And so and it's also key to note that the name of the parameters have nothing to do with the actual variable names that are being passed in. It can be completely different. So I can put num1, which is of type int, and I can put number2, which is also of type int. One thing I could also do, because both of these are integers, is I could actually just have int in there once and separate these with commas and say number2 like that. So that works, and this only works here because both of these parameters are the same type. But if they were different, then I'd have to follow both of them up with their defined types. Now, as I said, the next part is to actually indicate the return type. So this function returns an integer, and then within curly braces is where I'm actually going to write my logic. So I'm going to just type in return number1 plus number2, right? And so one thing I could have done is, create a variable on this line here and store number1 plus number2 in that variable, then return that variable. But that's just more typing, that's more code. So it's easier just to return the result of number1 plus number2, and that returns this integer, so that's going to get stored in my sum here, and then I can print out that variable here. So format.println my sum, and then we'll run this, and we can see that the result is 6 there. Also, I could have just taken this whole expression here, and just put it straight into the format.println, and there's no need to actually even create another variable. I could have done it this way, and if I run it, you'll see that we get the exact same result. I also mentioned that it's possible to return 2 different values or just multiple values from a function. You can return 2, 3, or more. However, in most cases, you don't want to return more than 2 return types. But for example here, let's say I wanted to return 2 integers, and instead of calculating just the sum, I'm going to calculate the sum and difference here, right? And so, oops, if I can spell right, calculate sum and difference, and then instead of returning just one value, I actually will store these in a variable now. So we'll say my sum is equal to num1 plus number2, and we'll say that the difference is equal to number2 minus number1, right? Change this to this, and then what we can do here is return both of those values. So my sum comma my diff, and because we're returning 2 now, we should be able to easily see those get printed out. And then also the reason it's giving me an error here is because whenever you're returning more than one value, those have to be in parentheses as well. So I'll run this code here, and we can see that we get 2 returned values. Another unique features of functions in Go is that you can actually give names to the return type. So if I wanted to actually declare these variables here, I could do that. And then instead of this colon equals operator, which is only used when you are initializing a new variable, you just use the equal operator because we've already declared it. Now we're just giving it a value. And so again, I'll run that and we'll see that we get the same result. Now, one thing you may have noticed with the format.println function is that we can pass in any number of strings and it works just fine. But with the functions that we've defined here, this calculate sum and difference, we've defined it to only take in 2 parameters. So if we try to pass in the third one, we'd get a compile error. And the reason that println is able to do that is because Golang supports what's called Variadic functions. And what that means is that we can define a function that passes in basically an unknown number of values, and it will handle that just fine as long as we've declared the parameters to be able to accept that. And so let's say I wanted to just go back to a function that calculates the sum here, right? And instead of returning 2 values, I'm just going to return 1. In order to notate that I want to pass in a, unpredictable or undecided number of values, what you do is create, of course, the name of the parameter, just like normal, but in front of the type, you include 3 periods. And that means that this is now a variadic function, and I'm going to get rid of this logic here. And so now we can pass in any given number of values. So let's say that we pass in these 2. Well, both of these now get stored into this variable vals, which is actually a slice now. And so let's say I want to store those within this new variable called sum. Well, what I can do is actually create a for loop to loop through this slice of values called vals. So I'm going to use that syntax that we've discussed in the previous video for index, when I'm not going to use that variable, so I'm going to leave it as an underline. For index comma, I'll say v and range vals, and I'm going to add this to the sum. Oops, sum plus equals v, right? And then we're going to return the sum there. So now I can run this, and we get 6. And I can actually put in any number of variables here. I can put in 8, I can put in 9. Oops, let me get rid of that space there. 9. I can put in 5. I can run that again. And we get those values. One thing I could also do is replace all of these input values with a slice actually. So I could say I want to pass in a slice of integer of integer, and then place values within this slice. So I can still use those variables up top, second num. But if I'm going to pass in a slice as a variadic parameter, then I have to use the 3 dots here as well. Otherwise, it'll give me a compile error. So I can run this, and we see that we get that result. So again, if I'm going to use a slice as a variadic parameter, I wouldn't have been able to do something like this, with a comma in between. That's not allowed. And just to be clear on what's happening here, whenever you create this variadic parameter, whatever you passed in gets put into a slice. In fact, if I hover over it, you can see there that it's saying this is a slice of integer. So it doesn't matter whether you actually pass in a slice or you pass in individual parameters, they all get put in or copied over into this slice here. And that's why most of the time where you see a function that accepts variadic parameters, most of the time the function will include some type of looping statement that it goes through and iterates through this actual parameter or variable in order to perform some type of manipulation or copy them over or something like that. Now, there are a couple more things I want to show you guys in regards to returning values from a function. The first thing is something that you will often see in code, and I want to make sure you guys understand it when you see it. So I'm going to change this function. And by the way, if I haven't used this term already, when we're talking about the parameters and the return type of a function, that's often known as the function signature. So whenever you hear someone use that term, what's the function signature? That's what they're referring to. What's the input parameters and what does it return? But I'm going to change this function around here. Okay, so I've now made changes to this code here. And the first thing that I want to do is draw your attention to this error package that I have imported now. And the reason I'm importing this package is because for this function, calculate remainder, I'm now returning this error type, which is defined within this package. And so this calculate remainder function takes in a numerator and denominator. It first determines if the denominator is equal to 0, because if that is the case, we cannot determine the remainder. And so what we do is generate an instance of an error type, and the syntax for that, or the function for that, is errors.new, and then you pass in this string value here. So if that's the case, what we do is actually return 0 for this integer value, and then return the instance that we created on this line as the second return type. If the denominator is not 0, then that means we can determine the remainder. We calculate that, and then we return the remainder, and then for the second value we return nil, because nil is actually the 0 default value of this error type here, and that's essentially saying that no error was found. And so the reason I'm mentioning this is because you will often see functions in code. If you were to go through the packages, the Golang libraries, you'll often see functions that are returning a second value of type errors. And in regards to calling this function, what you'll see is that you generate or create two different variables. So here I'm initializing a variable called remainder and another one called error. And then what we'll do is actually implement some code that performs a check on the value of error. So what we'll say is if error is not equal to nil, because that's our goal. Hopefully error is equal to nil, which means that no error was returned. But if an error was returned, then we say format.println error, so that we know what the error was. Otherwise, we're going to do format.println, and we're going to print the remainder here. All right. So in this case, we shouldn't have any issues. There should be no error. So we have a remainder of 1. But if I was to change that denominator, which is actually this one here, to 0, what we'll see is that this line gets run here, cannot divide by 0. So just again, wanted to bring that to your attention. And then the second thing, as I mentioned, is that just like we can with the for loops using underscore for a variable that we don't want to use, we can do the same thing here. So if I wanted to say, maybe I just want to call a function that checks to see if an error is returned, and I never intend to do anything with the other return value. In that case, I can just use an underscore, and that's completely fine. And it's complaining here because I need to close that off there. And so I run that. And again, that's not a problem that we have this underscore because we're not using that variable. So I think what I've talked about so far is enough for this video. In the next video, what I want to do is elaborate on a term that I used earlier, which was first class functions. And what that means is that in Go, you can actually create variables that themselves hold functions. In addition, you can create functions that accept and return other functions. And I think it's appropriate that that information or that content is included in a tutorial all to itself, because that can be overwhelming. So hopefully this was helpful and makes sense for those of you who are completely new to the concept of functions. If it was not, please do ask questions. Let me know in the comments. Again, please like and subscribe. And I hope to see you guys in the next tutorial here on Esoteric Tech. Thanks for watching.